Hello, everybody. So my talk has kind of a strange title, Staying Above a Rising Security Waterline Through Software Engineering. So I'm not really sure what you guys might have thought that meant, but I kind of think of it as two things. One, where security is, you're trying to raise the security bar, so get better and better and better. And two, where you're constantly getting more and more requirements and things are getting harder and harder and harder. So it's also kind of at a high level about how to limit people from making mistakes in your organization, software engineering mistakes, and and finally about how I focus on a lot of what I do is focusing on getting security out of building high quality software. So not focusing on building security, focus on getting security as a byproduct of having really good software. And this is important because I work out in San Francisco at a startup that's growing really fast. So there's constantly new requirements and more and more and more to do. So I work at CloudFlare doing a lot of various different security things. This is my fourth time here at RVAsec and my first time speaking, which is cool. And I'm from this area, so that's why I really wanted to come speak at RVAsec. In the past, besides CloudFlare, I've done some independent work, and I've worked at LastPass, which is in Fairfax, which some people might use, so it's notable. Okay, so a rising security waterline at CloudFlare. What is CloudFlare? So we're actually one of the biggest networks in the world, and this is the peering exchange list, and we have peered with more networks than anyone. So, well, not more than anybody. Hurricane Electric beats us, but we'll beat them soon. And we're growing this network to be really big. We have, I think, 80 points of presence around the world in data centers everywhere. And we're processing, and what CloudFlare is it's a giant reverse proxy. So we sit on the network. How it works is it's software as a service. You have a website or a web service, and you change the name servers to be our name servers, and then we sit in the middle of all HTTP requests that go to your website. We become a trusted man in the middle. And so that means we have massive scale because our every request that the combination of all of our customers sees comes to us first. So we have to be able to handle all these requests. We have a lot of security features of like caching layer, WAF, firewalls, like this all the boring stuff that you would expect. But the mission of the company is to make the web faster and more secure. And then why is security important to us? Why does this waterline matter? So we have a lot of secrets, like I'm sure everybody does. So we give away SSL for free. So we have an SSL cert for every one of our customers, which is something that you probably really want to keep secret. Even free customers, you don't have to pay us anything when we give you an SSL cert. So it would kind of be like an end of business day where everybody just goes home if there's a pastebin dump of all of our customers' SSL certificates. The company would go out of business. So we really care about security for that. Reliability. So like I said, we handle all of our customers' HTTP requests. So If our customer is an online store, Amazon's not our customer, but they're a good example where reliability matters. If Amazon's down for a minute, they know it's a really big deal. It's millions of dollars a second. So we also do DDoS mitigation, and we consider our customers' real website IPs secret, even though there are things you can do to figure it out. Like if you know where it's hosted, you can narrow it down to a smaller set of IP addresses. But we know customers' IP addresses, but we don't want other people to know our customers' IP addresses. So they can't just circumvent our network by going right around us. And then there's regular customer settings that are secret, like regular businessy secrets. And then internal secrets. We have an internal certificate authority and a lot of internal infrastructure that we don't want outsiders to know. So security is really important. And what do I do here? So I kind of got hired, and they said, we have kind of more application security for more AppSec stuff. And they said, we have a lot of bugs, I'm sure. Why don't you go find them and then fix them? And we've got hundreds of code repos to keep you happy, and go at it. And that isn't what I did at all, because that is a huge waste of time. So if I just did that, there's so many more engineers who know way more about the code base. So what I'm going to talk about here and is more what I do every day. It's more my day-to-day operation. So I spend time security, like triaging security bugs, but then that's the easy part, is making sure that they don't happen next time and in the future. And what happens if everybody at the company quits tomorrow and they hire new people and have the same code base, and you still want the security bug to not come back. And like I said before, the software engineering this is kind of the combination of software engineering and application security. Oh, that's not supposed to happen. Okay, so today in modern software applications, modern software as a service applications, they're going from a monolith, which is one big poop emoji, to microservices, which are a lot of much smaller poop emojis, distributed poop emojis. And this is what things look like today. And it presents new challenges to keep it secure. Before you had one big thing to protect, and now things are more distributed, things are better connected. It's the way things are going. So, dang, there we go. So microservices are when you split up your services into smaller bits, where not actual bits, but smaller parts, where the parts make up a whole application. And it's supposed to, the goal of microservices is to make the code simpler, which you think would lead to less security issues, because you're dealing with simpler code. There's fewer problems that can happen. There's not as much complexity all in one place, and it sounds like everything would be great, but they actually become really difficult to deal with operationally. And so if you're not ready for this new change, which a lot of people, this is a very new idea, so people are still figuring it out, and operationally it's a nightmare because people are doing it all wrong. So from an application security perspective, what do I do here? Do I review each small part? And how do I approach that? Should I really waste my time and dive into each separate part separately, or how much cohesion is there between all these different microsystems? And like I said, doing microservices wrong is really easy, and tons of people are doing it wrong. And a lot of these operational issues are security issues that we mentioned earlier. So how do you handle high latency, circular dependencies? Are you equipped to trace operational issues? So if someone can bring down one of your microservices and you have other microservices that depend on it, the whole structure, it's a house of cards and everything will go down. And reliability is key. So you're setting yourself up for failure. So security is kind of central and has to be like thought of at the very beginning of going into this microservice world. And people aren't really doing that right now, but things are getting better. So at CloudFlare, we do a microservice thing, and I think we've done a pretty good job. Accidentally is how it started, but I think we did a really good job. So it makes me happy, it makes the operations people happy, but all of them look the same. And this is key for security. If you're building all these things, they should all look the same. If you're building a lot of things that are part of a whole, it makes sense. So we have very loosely, these are just a couple requirements. All of our microservices have a make file, they all have a Docker file, they're all written in Go, and so if someone quits and their part, and they worked on one part of the whole, anybody can kind of jump in and be up to speed on it. It's kind of, the way I think about this, having a standard for what your services and having a standard for what your software looks like. It's just like having a style guideline when you're writing style guides, when you're writing code. Never mind. So what does this mean for like you as a application security person or you as an information security person when you're dealing with a standard way that services should look? It means that you're going to have a lot more code reuse, because if all of our code is Go, we're going to share the same libraries, which is good. You're going to have fewer questions to ask. Instead of when you're looking at each part of this big system, it's a lot easier to understand all the ins and outs. And there's going to be fewer burdens to get started looking at all these different systems. So if someone says, hey, here's a new one, you know pretty well how to handle tackling this new system. And it makes going forward a lot easier. So let's say you add 100 new services to this poop emoji cluster. You're in pretty good shape because you kind of have an expectation of what that looks like and what that means. And it allows you to focus on what's different about each one. So if all of your services are a Venn diagram and they all look like this, then the space in the center of the Venn diagram is pretty big, and it just leaves a little bit around the edges that you have to look at for each different service. And this is good for everybody, operations people, just running your software business. It's good to have this. And another thing that I focus on a lot is secure interfaces. And secure interfaces, I say up here, APIs that are designed to help developers make fewer mistakes. And this is something that I care a lot about. And I think the reason a lot of, this is funny, I wrote this, the reason a lot of security companies exist is because people didn't do this. And we'll get to examples of why in just a second, but I think that providing secure defaults for code that you write and libraries and for your developers, so this can be for infrastructure, this can be for anything. Secure defaults really matter, and anytime you add a default value, you really should think about it to a system, whether it's like Linux, how does SSH come pre-set up, whether it's anything, it all really matters. And you should, interfaces should abstract away the difficult parts. Like, not everybody understands really difficult things about infrastructure and about code, and they don't have the same levels of subject matter expertise that the people who built it have. So it's about like helping the future people who come around and look at this be able to handle it. And so, like I said, a lot of security companies exist because people didn't do that. And here's probably why. So does anybody think this is a good secure interface? So this is the string copy in C, where you have, you copy a source to a destination character pointer, character array.
Don't have developers manipulate strings in the first place? Don't have developers manipulating strings in the first place, correct? Just have them abstracted away.
Yeah, I agree. But this is just an example of, is this a good interface or not? It doesn't have to be whether it's, it doesn't matter where it's at, right? Like there's room for improvement. And they tried to do that with stern copy, and eventually Sterl copy is really good. So the problem is this is like kind of a classic example of a line of code that can go really horribly wrong if the source is bigger than the destination in string copy. You'll corrupt your memory, and this can lead to really bad things. And stern copy tried to, I don't know all the C history and all this, but I imagine that str copy came first, then stern copy, which has this length so you can prevent yourself from overrunning your buffer. But I think we can do better. And this is actually right up the alley of the person who asked the question. Why don't you just not manipulate memory? Well, what about if you just copy a source and you get back a pointer? I think that's a lot better. This is like not good. It has other implications in C. This wouldn't be good code to actually have. But it's kind of abstracting away this idea of manipulating memory yourself and needing to understand all these details before you use it. And in the real world, there is a really good secure interface that I like, and it's called an AEAD interface, and it's open and sealed. And so for years and years and years, people have been writing crypto code that is wrong, and they get it wrong constantly. So before, there was a huge barrier to enter to write crypto code. You had to, someone gives you a requirement and says, encrypt this string. You're gonna look up, okay, how do I encrypt something? Let me Google Stack Overflow, encrypt something. You see AES or DES or some algorithm, and you copy the code, and you end up with something that probably is not secure and probably not good. And this went on for probably 30 or something years, where people were writing code that they didn't fully understand that was crypto code. And the problem wasn't that the crypto code is, the problem wasn't with the requirements. The problem was there was no tool to help people be successful at writing this crypto code. And so the AEAD interface came out, and it's an attempt to remedy this. It's in the SALT library, and this is open and seal. So the idea is you call seal, developer calls seal, it encrypts securely. The developer calls open, it decrypts. And they don't need to understand all the ins and outs of like ciphertext padding, of choosing a block cipher mode, of choosing a cipher, of all these complexities that that cryptographers worry about. There should just be an easy way to encrypt and decrypt things securely, and that's what this is for. There's really only one issue that still remains with it, and that's nonce reuse. If you look, you can reuse this nonce parameter multiple times, and that's really bad. I think they tell you in the docs don't do that. But they still allow you to shoot yourself in the foot a little bit. This is a really big step forward for software development and cryptography, because if this is successful, like more things will get secure interfaces, and there'll be less security bugs and less need for people who do application security. So now you know what to do if you ever need to encrypt something. Just use an AAD. Okay, so next is a pretty interesting story about secure interfaces that I found on the open web that started at work through just these two principles, just focusing on secure interfaces and focusing on focusing on how to solve things for the entire cluster of poop emojis instead of just one individual emoji. And this is cores. So I found a bug at work one day where someone had misconfigured something. It's called cores, cross-origin resource sharing. And it's a way to poke a hole in the foundation of all web security. All web security is based on what's called same origin policy. And cores is used to poke a tiny hole in that, because sometimes you might want to have two things that shouldn't by default be able to talk, and you want them to. So cores is a way to do that. And an example is having a page like Google make a request, or in this case, example one is requesting example two, but Google shouldn't be able to write code that makes a request to Bank of America and steals all your banking information. Your browsers will stop that. And cores allows you to poke that hole if you're Bank of America, to allow Google to. And it works with a special HTTP headers. So if you're familiar with HTTP, this should be fairly simple. So the bug was cores was really misconfigured when I saw it, where the engineer had not realized that they were just reflecting what came as the origin header. So the origin header, this is a really confusing topic to stand up and talk about. But the developer had basically opened a hole where anybody who wanted to could access the website. They were poking a hole for anybody. And that meant that people could, the actual attack is really complicated of how this is exploited. So if you open this hole for anyone, what happens is you could go to an evil website, and the evil website makes a request to Bank of America, and Bank of America says yes, and they shouldn't. So what I did was I wrote a secure interface around this process of picking who to allow to talk, your website can talk to, who you can poke holes for. So it's very restricted, so you can't open it up for anybody. And I gave this to all the engineers. So it's a lot easier to maintain. So engineers who come in the future don't need to understand this really complicated system, because CORS by itself, this cross-origin resource sharing and poking holes, is super complicated. There's like 4 HTTP response headers that you have to send back, and there's all this weird oddities that your browser will do to see if you're allowed to, if this is an actual hole that's been poked by Bank of America. It gets really, really complicated. So it can't be expected that everybody understands this. And so I wrote this security interface around it. So it's just a small whitelist of sites you can poke a hole for. And gave it to everybody. And oh, wait. And this got me thinking, though. So my coworker did this, and I think my coworker is a really good engineer, and he just misunderstood this specification. It's an RFC of what browsers should do for these 4 headers that get handled. I think that this is like a big misunderstanding, and other people might have done this. So I scanned the Alexa top 1,000,000 for this bug, and like 1,000 were completely misconfigured, so that anybody could bypass same origin policy, this glue that holds all of web security together, and steal. I wrote a proof of concept and attacked myself, and I could steal Bitcoin, I could steal credit card information from sites that took credit cards, I could steal all this really, really scary stuff that you shouldn't be able to steal. And I think that goes to show how important security interfaces are around complexity. Like you can't expect everybody to understand really complex concepts. And that's kind of what we do as security people. A lot of people work in big organizations and smaller organizations, and sometimes there's complexity that we understand with systems that other people don't, and it doesn't really help to just point at a problem and say this has to get fixed, because it's just going to get repeated and repeated and repeated until the problem is fixed at its core, or you abstract away all this complexity from the people who make the mistakes. And worst is me finding that all of these websites are misconfigured. If you have any ideas of what I should do, because they're still out there and they're all still really open, I'm not going to go hunting down like 1,000 email addresses, but like you can't really get a CVE for it because it's people misunderstanding something, and you can't really, and it's not one place they're misconfigured. Like it's not one little library that's wrong. It's tons and tons of people misunderstanding this, and it's the glue of all of web security. So it's like I'm kind of in a tough spot with it. And so, so my talk is a little more from the perspective of software as a service, like running a big network or a big software project, or keeping things online, kind of more a little different from what I know a lot of people here do. It's not it's a little different. But a lot of times the coordination and communication and maturity when you approach solving a problem at its core and not just patching. Like, patches are the worst. You patch something and it's going to be outdated shortly, or you write some code to fix something and it's not going to, and someone else will repeat the same bug over and over again. Like, these, unless you solve security issues at their very core, then they just get repeated, or they just continue on or manifest themselves elsewhere. And since I said this is kind of like the combination of software engineering meets security, I work with software engineers. So a lot of times what helps me is what helps them as well. So if they're running into the same problem tons and tons of times, I can help them by making them more secure and abstracting away complex things, and make their life easier too by them not having to worry about this stuff, all this security business. They don't care. They just want to do their job. They have requirements, and it helps everybody. All right. Thank you, guys.